Hey guys, welcome back. Today we're going to be doing another Geometry Nodes grid tutorial. We're doing more volume stuff. This time it's kind of like the more cleaned up version of the past video. I've learned some more things and I want to share it with you guys. And so let's just jump right in. So when we're working with fluids in kind of geometry node systems with grids, it's important to think about kind of like the flow of the data of everything. So we're going into geometry nodes. We're going to have this mesh be like our boundary zone. Kind of like our simulation domain size. And we'll also have a different target mesh we want to deform. To make it easy, let's just do a mesh Suzanne. Let's scale a little bit. To apply the scale, grab X, pull it over here. Let's actually add a subdivision surface modifier. Nice. And then let's go into here and let's just drag it in. And now when we're working with this, we're going to want to actually probably increase this domain size. It's also can be called an Eulerian grid, because this is going to be basically where all of the calculations have to happen. That needs to be in a larger space. So like, I guess if we want to, thinking about the domain size, if we want to deform the Suzanne, right, we got to have the grid size be larger than it so that the vectors and all of the different points inside of it are going to be encompassing inside of it. Like encompassing over the actual minimum requirements just for this space inside here. That's important because if it's different, like if it's not that same size, then it's going to like smash into those invisible boundary walls and it's not going to look like a clean displacement. So we're going to go into here. We're going to be doing a mesh to volume, I think. No, we're going to do a mesh to density grid. Perfect. This comes in. Let's actually do a transform geometry. Let's just double the size. So now it's going from this to that. Honestly, that could be too big. Maybe like 1.5 seems reasonable. And it's going into this density grid. So now we got to store that density grid somewhere. So if we do store named grid, we can then have this coming in right here. And so then this can go through and now it's a volume. Isn't that cool? So it's a little bit confusing because it has this volume spot right there, but you don't need to actually have it like go through. You can just kind of chain them together. So let's call this our simulation domain. So let's say sim domain. So now we look at this, we look at the volume grids right here. We have one called a sim domain, and we also see the size of it. It's 2.5 megabytes. If it gets bigger, it can get pretty huge. So let's do another one for the Suzanne, and then let's make sure this is also correct. And it should be in the original position, not the relative offset, because that's why we have it over there. So that looks good. And we can then store this as well. And let's call this into a deform mesh, right? Now we have this. Now they are both lost into the kind of the overall, they're kind of both lost in the overall volume we're seeing. If we look at just this, let's see if we can do it. We can see we have the density grid of just that. Probably want to increase the voxel size or decrease it to like 0.1. Now we're getting a better view of it. Maybe decrease this one a little bit too. And then the gradient is just saying in between these spots, how is it like averaging these points? So it's giving a 0.2 meters for all these different things. And the 0.1 is the size of the voxels, right? So we have all of this going through, and now we're going to want to advect it. So how can we do this? I guess we can do this just with a grid advect grid node right here. If we plop this in right here, and then we used, make it easier to see, let's make it 5. And then if we used like a noise texture, if we try to use a noise texture to advect the grid right here, like we're seeing, we're getting an error because it's not a volume grid. So we have to do a field to grid node right here. And what is the overall like field we want to sample? It's actually this sim domain back here. So if you do this, we now have that. You can pop that in there. You can also do a vector math. Vector math. Nice. And then if this gets a bit bigger, you can see it's doing a noise, like it's displacing all of it over time, as we can see. As I'm clicking right here, I'm doing small time domain changes, and we're seeing the density shift, which is kind of cool. It looks like a cloud. That's what's happening. It's fluid dynamics right there. But we should do small steps over time. Small steps over time. What is that? It's a simulation zone. So simulation, we're going to cut this. I'm going to plug this in here, volume to volume out. And then this can go back to 1, the density right here. That was just the general explanation. So now we want to have this same kind of steps coming through to advect the density grid. So let's also do a sample named or get named grid. We have this coming through here. We don't want to remove different grids. We want to just get the specific one we want, which is called deform mesh. And that's going to be coming into here. And we're going to do another store to change it. And that's going into here. Perfect. And so then if we do that, and we also were to do a get named grid and say grid to mesh, add this, pop it in. Now we have our way of looking at everything. So if we play this over time, it will deform and advect over time as we're seeing right here. So we're getting a general kind of displacement of everything. So we're getting these blocks. It's not looking clean. It's like, why is that? It's because our noise probably is too big. We made it way smaller and rerun it. Probably gonna get a better noise displacement as we're seeing right here, but it's still breaking apart into kind of blocks and cubes. That could just be the general shape of the noise. If we were to make this smaller, it's probably going to lead us to a better view of the noise, but we are seeing these same cubes right there, right? You can kind of see it. Maybe the YouTube compression won't show it, but there is kind of like a cube inside of that. So if we were to do Voxelize grid, I think it actually will work. So we're forcing that grid to make it everything be voxelized. So what's happening, this is actually a really important concept in Blender. So we have this on and off. I don't know if you'll see it, but like, man, it's like hard to see, but there's like right here, there's like this tile, right? So in Blender, the way it's going to be saving space for you is if it sees values that are really close to the same. So let's say like inside this tile, let's say the value is like 1, 1, 1, 1 for all of them. And I think it's 8 by 8 voxels actually for the tiles. It might be 8 by 8, then it goes to 16 by 16 for larger tiles. If this is all the same number, to save space for the voxels in the memory, it's going to make all of this be 1, right? But Voxelize grid says ignore that, make it all discrete, and make sure it has values for everything. And that's why it kind of goes away and it will fix the problem. So let's just do that really quick. We turn M to turn it back on. Let's check this. It's running. Yes, the noise looks a lot better because we turned on the Voxelize. So now it's just going to have every single spot be working. And let's also look at the size difference. It probably should be different size. 2.6 versus, I guess it's the same, 2.6, whatever, it's fine. But as you can see, the number of leaf tiles between these is different. So that's nice to see. Nice. And we're kind of having this explode out. It's doing its thing. And then when it hits the edge, as you can see right here, it will kind of stop moving and then the noise kind of clips. So this is the density grid size right there. As you can see, it hit that boundary, had some nice noise right there. Then it just explodes out doing some weird blobby stuff. It's fine, but it's not kind of what we want. So how can we have it kind of move around and explode and not have to deal with that? It sounds like we want a curl field. So grid curl. So then the grid curl node is going to take that vector of that noise and make sure it's divergence-free, as in it's not going to leave the overall boundary. It will swirl and make that kind of cool motion. We plug it into here. Let's see how it changes the overall displacement of everything. It's going quite quick. Looks a lot cooler, right? And it's kind of hitting that boundary and it's not really going anywhere and it's staying consistently inside. Eventually goes away because the density probably leaves the overall simulation boundary, which is fine. If we look at this, we can see the difference between the two, right? So if we make this a little bit bigger, which is going to cost more to compute, and rerun it, we're going to see a different animation. Looks pretty cool. We're getting these different little branching paths, which is nice. That should work. So let's actually make this even smaller. And now we have even better motion for everything. Nice. It's like exploding out. Looks cool. Getting this really clean motion. If I made this bigger, let's see what happens. That's fine. It doesn't really matter. Nice. So we're having this really cool displacement. It looks nice. I think really lowering the overall value of it is helpful. Make that overall step smaller. Moves a lot smaller. We can change this to be rung at cut of 4. It's a bit more expensive, but has a bit of a cleaner motion with the fluid dynamics. It's moving. Looks good. And so then what we want to do is also slow this down a bit more. So how can we do that? What we do is we take a vector math and we do a scale node, plug this in, plug it in, and scale it by 0.2, even less noise. And then it will go way slower. And maybe you want to have it go like slower in the beginning and have it go faster towards the end, which I think is kind of be nicer for the overall animation. So if we do a scene time node and we use the overall frame count, we say divide, and let's divide it by like 30, right? So look at this number, right? It goes past that. If we clamp it, it'll be stuck to 1. So it goes from 0 to 1 at 30 frames. Then it goes to whatever we want. So if we plug this into a math node of multiply, and then this is going to be the number we're going to be scaling. And let's say we want to have it be like 0.5. So it starts off slow, and then the animation increases speed after you go. And so the whole fun of it is working with that noise texture and seeing what is a good one that we like to how that way. Working with that noise texture and seeing what is a good one that we like, how it's kind of displacing the mesh. I think this is what I'm going to be working with. I'm happy with this guy. Make some nice ripples. It looks cool. Maybe increase the scale, see what happens. It's too much. Let's just do 1. I think that looks kind of nice. I might slow it down another chunk. I want the first second to all be slowed. So let's do 60 FPS. I think the overall speed's too much. Let's lower that down. Nice. It's looking nice. It almost looks like coral or something. How everything's kind of moving and diverging. Looks good. And there's also a way to kind of smooth it out if we use the grid median versus the grid mean. Grid median will take kind of the actual average value. So it will allow for more of these kind of spikies to be kind of more extreme. So I think 2 iterations of that's kind of nice. It smooths it out a little bit, which is good. And then what we can do is also do a set shade smooth. And then now we have this kind of blobby shape. Looks nice. We also can do a set position node and then do a blur attribute. And we do a position node of itself, like so. That's also a way to smooth it out a little bit. So we'll go down to nothing, just see. I think just 1 step of blur, maybe 2. There we go. And that's gonna be a good way of getting the overall shape to look a bit more reasonable. Let's do 240 frames, it's about 4 seconds. Let's bake it. We'll do a bake. Pop this puppy in, do the animation, bake it. Nice, let's see how this looks. Spans out. I think it's looking pretty cool. Let's set a material and set the scene as fast as possible. It's a really quick one. Nice, so I was able to finish up the effect. I'm gonna finish rendering it out, but this is the material I basically chose. Added a bunch of lights to make it interesting, and then the rest of this is kind of things you can just figure out yourself for how you have your own kind of preferences. Let's go over the effect one more time so we make sure we all agree on how it works. So we're going into the geometry nodes. We're taking in our initial geometry to be our simulation domain, or it could be, you know, also called our Eulerian grid for calculating all of these different things. It's going to be looking like this, right? And then we also are going to voxelize that grid, which will allow us to take a cleaner field to grid node later on in the chain right here, right? And so then when looking at this, we're going to also take a cleaner grid to field to grid node right here, which is good too. And looking at this, we're also going to be taking in a different mesh to grid, which is going to be our mesh we want to distort and change. So we're using the Suzanne head. We're using the Suzanne head right here. We're using a store named grid node to capture both of these. We're putting it into a simulation zone, and we're referencing that grid with the get named grid, and we're advecting it with a curled noise texture using that simulation domain field right here to be the one where the curl field is going to be calculated. We're going to be using a really small time step in the advect, and we're also going to be doing this trick right here where we take the frames and we do a clamped math node in order to have the initial 60 frames be slower, and eventually we'll scale up to a 0.2 for the scaling right here, right? We're then going to take that grid, we're going to turn a grid to mesh, but also smooth out some of the roughness with a grid mean, and a set position with a blur, and that was able to give us kind of this smooth, kind of blobby look. So it's really quite straightforward. It's something that pretty much anyone can do, irrespective of your Blender kind of experience. In my catalog, there'll be some more grid node tutorials to better kind of show the workflows that I've been learning as I'm messing around with them. Thanks so much for watching, and see you next time.
Augury.